Hey, what's up? This is Randy. As you can see, today's topic is graphs of logarithmic functions. These are quite similar to exponential functions, but one of the major differences is that these logarithmic functions have vertical asymptotes, while the exponential functions had horizontal asymptotes. Here we go. So we'll start today by looking at the parent graph for logarithmic functions, and then we'll look at how that parent graph can be transformed, that is, how it can be scaled, reflected, or shifted. And then finally, we will do some example problems. So what we're looking at right here is the graph of log base 2 of x. Now, something that's very interesting is if you were to reflect this graph over this diagonal line, which is y equals x, what do you think we would get on the other side of that diagonal line? On the other side of that diagonal line, you would actually get the graph y equals 2 to the power of x, which we just recently saw in a previous video. Now, by this point, hopefully you're getting pretty used to seeing formulas like this. This formula will dictate how our graph will be transformed. So what I'm going to do first is let you pause the video in a moment and read about each of these types of transformations. So I'm going to let you pause the video now and read through all of this, trying to understand all of it as well as you can, and then we'll talk about it together. So assuming that you have read all of this, I'm going to go back to the graph now and describe each of these transformations to you in my own words. So let's start with this variable a. If a is positive, the graph will not be reflected vertically, but if it's negative, it will be reflected vertically. You should be very used to seeing vertical transformations by this point. Now, if a is more than 1 or less than -1, the graph will be vertically stretched. If a is between -1 and 1, the graph will be vertically compressed. However, for this lesson specifically, you will only see values for a that are 1 or -1. Now, you're going to see values for b that are relatively small positive integers, such as 2 or 3 or something like that. And finally, as you would probably expect, this minus h will dictate the horizontal shift, and this plus k will dictate the vertical shift. Minus h is right, and plus h is left. Plus k is up, and minus k is down. Now let's do some examples to practice identifying these different types of transformations. All right, so as usual, here is our guide, and we are told that the equation of the green curve f of x, here's f of x, is given below, and that is log base 2 of x. And they say, what could be the equation for the blue curve, g of x? So let's try to identify the transformations that took place. So with logarithms, the easiest transformation to identify first of all will be the horizontal shift, because in this case we know that there was no reflection. So as I mentioned in the introduction, logarithms have vertical asymptotes. We can see that the asymptote of f of x was shifted 1, 2, 3 units to the right as we got g of x. So a rightward shift means that we will have minus something in place of minus h. In this case, it's minus 3. So I see minus 3, and minus 3, but right here we have plus 3. So the answer could not be C. Now let's try to decide between A, B, and D. Well, letter A is like saying -1 times log base 2. So that would make A -1, which indicates a vertical reflection. We know that a vertical reflection did not take place, so A also could not be the answer. As usual, I should mention, don't keep watching this video if you haven't tried the examples first, or at least this first one, and then pause it before I do the second one as well. All right, assuming that you've tried yourself, let's try to decide now between letter B and letter D. How could we determine which of these two answers is correct? So as the graph was transformed from this green curve to this blue curve, did it shift up or down? Clearly down, right? we can see that the blue curve is lower than the green curve. So the answer would need to involve a minus k, and here we have a minus 2. So D is the only possible answer. But how do we know that it was exactly minus 2? Well, with logarithms, what you can do is find the point that is exactly 1 unit to the right of the asymptote. So on f of x, it's that point right there. And on g of x, it is this point right here. And then we just need to determine how far did that point move vertically. That point moved 1, 2 units down. So that's where we get the minus 2. All right, now let's try an example that involves a reflection. This time we have log base 3 of x, and I can see that option A definitely will not be the answer because the value for A is positive 1 in this option, while the rest are negative. So let's eliminate A immediately and now try to decide between B, C, and D. Okay, so here are our two asymptotes. How far did the asymptote move? Well, going from the green curve to the blue curve, it moved 1, 2 units. So that means that the horizontal movement is left 2. A leftward shift is going to give us plus h. In this case, it's going to be plus 2. So here I see plus 2, minus 2, and plus 2. So this answer could not be C because this minus 2 indicates a rightward shift, but we shifted left. Now, in order to get the blue curve, we either shifted down 1 or up 1. This is harder to answer when we've been reflected. So let's talk about how to identify for sure how much we shifted vertically. Now, for logarithms, find the point that is exactly 1 unit from the asymptote on both curves. So here is that point on the blue curve, and here is that point on the green curve. Now, for logarithms that have been reflected, it is very important that you choose the point that is exactly 1 unit from the asymptote. No less, no more. Because if you choose a point that is not exactly 1 unit from the asymptote, this logic will actually not apply. The reason that's the case is because the vertical reflection actually happened about this point, okay? If you don't fully understand that reasoning for why, don't worry, you can still solve these problems. The point is, we have now identified both of those points, and we can be sure that the vertical movement will correspond to the equation. So what was the vertical movement from the point on the green curve to the point on the blue curve? Well, obviously, it was down 1, which means that the only possible answer is B. So these problems will probably feel a bit strange at first, but just remember to take it one step at a time and always remember the meaning of each of these variables, and you'll do just fine. And that's everything for today. See you next time. Hey.